Alright, if I am calculating the sides of a right triangle, then I have my SOHCAHTOA. In the diagram, we're required to determine the measure of side length B to C. So this side length here that they've labeled as X. Relative to the 49-degree angle that we know, the side given is the hypotenuse here, and I'm trying to solve for the opposite. Well, the only one that includes opposite and hypotenuse is sine, so I can say sine of 49 degrees is equal to x over 17.6, or the opposite over the hypotenuse. And then I'm going to multiply both sides by 17.6 to get x by itself. 17.6 times sine of 49 is equal to x. And then I can actually just multiply that in my calculator. To one decimal place, 17.6 times sine of 49 is going to be 13.3, which means that the length of BC is going to be 13.3. We don't have units to measure this, so we're just going to have to say 13.3. For the next example of it, it's stating that relative to the 73-degree angle, I know my adjacent, and I'm trying to solve for my hypotenuse. Well, the only one that has adjacent and hypotenuse is cos. So cos of 73 degrees is equal to my adjacent 24 divided by my hypotenuse, which they have represented by A. The first thing I need to do is I'm going to multiply both sides by A to get this A out of the bottom. I'm going to say A times cos 73 is equal to 24, and then to get A by itself, I'm going to divide both sides by cos of 73. So the hypotenuse is going to equal 24 divided by cos of 73, and when I put that into my calculator, I'm going to get 82.1, which means that the length of QR is 82.1. For this example, if we're using the trigonometric ratios to determine the lengths of AB and AC, well, I have my angle here, and I'm going to label these sides. I'm going to call AB X, and I'm going to call AC Y. And we're going to solve for AB first. Well, if this is my angle, if I'm labeling all the sides, then y is going to be my hypotenuse, x is going to be my opposite from the angle, and the 109 is going to be my adjacent. If I want to solve for x first, well, I'm going to have opposite and adjacent, which means that it has to be tan. So I'm going to say that tan of 74 degrees is going to equal my opposite, x, over my adjacent 109. And then to get x by itself, I'm going to multiply both sides by 109. So x is going to equal 109 times tan of 74. And x is going to equal 380 feet. For y, I'm solving my hypotenuse. I know my adjacent. The only one that has adjacent and hypotenuse is going to be cos of 74 is going to equal 109 over y. I'm going to multiply y into both sides and say that y times cos of 74 is equal to 109. And then to get y by itself, I'm going to divide both sides by cos 74. Y is equal to 109 over cos of 74. And in this case, y is equal to 395 feet. For example 5, we're going to put in a little bit more problem solving. A large tree is to be transported to a new location. The tree is held vertical by means of two guy wires of unequal lengths on opposite sides of the tree. One wire makes a 48-degree angle with the ground. The other one is 12 meters long and makes a 56-degree angle with the ground. Both of them are attached 3 meters down from the top of the tree. So first I'm going to do my best to draw what this is going to look like. So I'm going to state that I have the two wires are going to be attached on opposite sides of the tree. So if I go straight up and down the tree, then they're going to be attached on opposite sides, and one is going to make an angle of 48 degrees with the ground. And remember that says it's attached 3 meters down from the top of the tree. The other one is going to be 12 meters long and an angle of 56 degrees with the ground. I'm going to label the side lengths that I don't know. I'm going to call the height between the ground and 3 meters right down from the tree, I'm going to call that X. I'm going to call the wire length that I don't know Y. And I can call the space between these two A and B. So, the first thing it wants us to do is it wants us to determine the height of the tree to 1 decimal place. Well, if I know the angle here, I know the hypotenuse is 12 meters long, I can solve for what the opposite side length, or X, is. So first, if I'm trying to solve for X, I'm going to say that, well, if I have opposite and hypotenuse, then I'm going to be using sine of 56 degrees is equal to X over 12, which means that X is going to equal 12 times sine of 56. And if I'm doing it to 1 decimal place, 12 times sine of 56 is going to be 9.9 meters. There's still the extra 3 meters, which means the height of the tree is going to equal X plus 3, which is equal to 9.9 plus 3, or 12.9 meters. If I'm determining the length of the other wire to the nearest tenth of a meter, then I'm going to state that this angle, I have now solved for the opposite, and I'm trying to find the hypotenuse. So sine 48 is going to equal the opposite, X, over the hypotenuse, Y. Or that sine of 48 is going to equal 9.9 over Y, because we already solved that one. In order to get Y by itself, I'm going to multiply both sides by Y. Y is equal to, Y times sine 48 is equal to approximately 9.9, or Y is equal to 9.9 divided by sine of 48, which is going to give me a length of 13.4 meters. If I want to determine to the nearest tenth of a meter the horizontal distance at ground level between these two wires, then in both cases I need to solve for what the adjacents are, and I'm going to solve them. So first I'm going to start by solving A. I'm going to state that if I'm solving for A, then I know that this is going to be 12 meters, and I can say that, or I can use the 9.9 meters, doesn't really matter. But I'm going to use the 12 meters because I know it's exact, and I'm going to say that cos of 56 is equal to my adjacent A divided by that 12 meters, which means that A is going to equal to 12 times cos of 56. A is equal to 6.710. I know that cos of 48 is going to equal B over 13.4 meters that we just solved, which means B is going to equal 13.4 times cos of 48, or B is going to equal 8.958. The distance on the ground is going to be the combination of A and B, which means the distance is equal to A plus B, which is equal to 6.710 plus 8.958 to the nearest tenth of a meter, 15.7 meters. And for part E, the guy wire in C breaks and a new wire of the same length is attached 2 meters down from the top of the tree. Calculate to the nearest degree the angle which this guy wire makes with the ground. Well, if I'm looking at part C, then what we solved for in C was this length y. If this one is going to break and we attach a new wire 2 meters down from the top of the tree, then what's happened is the length of B has stayed the same and the length of X has increased by 1. So I can say that suddenly, if I draw out another little sketch of this, then I have a wire that's going to be the length of 13.4, which we already solved. And then on this side, it was originally 9.9, but I had to move it up 1 meter to attach it 2 meters from the top, which means that this is going to be 10.9. And I'm solving for the new angle, x degrees, that exists here. Well, I have my opposite and I have my hypotenuse. So sine of x is going to equal 10.9 over 13.4, which means that x degrees is going to equal sine to the negative 1 of 10.9 over 13.4, which is now going to equal 54 degrees.